Okay, what we're going to try to do here is just pick a point and try to estimate the direction of the gradient and estimate the length of the gradient. I suppose we could try to write down coordinates too, but we'll just see. So I'm going to pick the easiest point I can see that I would be right there. Actual coordinates of the point aren't that important to me. We can see that the z values are going up by 0.25 each time, and so in order to get off this contour as quickly as possible in the direction of greatest increase, I'm going to have to go perpendicular through that point. So what I'm going to do is just make sure I'm going perpendicular as much as I can, like this, and then I'm going to need both sides of the point because we need to estimate the slope. So I'm going to go like this, and we at least have drawn the direction of the gradient vector. Yay, that's the direction of the gradient vector. Now, if I actually had to give coordinates for this, I can see, for example, that it goes down, thinking about 0.6, and it goes over from about 1.75 to about 4.1, right? 4.7, let's see, 1.71 to 1.7, let's see here, wait a second, this comes down about here, that's about 1.9, this comes down to right here, that's about 4.25, that's 2.25, it's okay, so I have, if I'm just writing this as a vector, right, it goes over about 2.35, and it goes down, I'm thinking about negative 0.6. Now that is the direction of the gradient, but that is not the length of the gradient. In order to find the length of the gradient, what I have to do is find the slope in that direction. So what we're going to do is we're going to say the length of the gradient in that direction should be something like rise over run. And I'm going to be estimating all of this. The rise, again, from a point before to the point after was 0.5. The run is the length of that distance, so I'm just going to bring that down to about here. I'll try again. Let's see, I'm going to start right, let's do inches. How about like that? More comfortable with that. What I'm going to get, let's see here, is about right there. So I'll just put my finger there, come down to like there, and I can see that the length is about 0.6, I think. The length should be about 0.6. I'm sorry, the run should be about 0.6. Like this. So 0.6. 0.5 divided by 0.6 is about 0.8. I'm just estimating here. So I want a vector that's length 0.8, so that's pretty darn short. Yes, in the direction of this, we can certainly write all that out without killing ourselves too much. I'm going to take the length, which I decided was about 0.8. I want to take our vector, which is 2.35 minus 0.6 like that, and divide by the length of all that. So I'm going to get 2.35 squared like this, plus minus 0.6 squared like that, and that is actually the vector we want. Ta-da! And again, just a reminder of what we did. We picked a point. We found the direction of the gradient, which was in the direction of greatest increase. We estimated the vector that was actually a vector that was pointing in that direction. And then what we needed to do is find the slope in that direction, because the length of the gradient vector is the slope at that point in the direction of the gradient vector. We found that slope was about 0.8, so we needed a vector that was in this direction whose length was 0.8. So we just took the vector divided by its length and multiplied by 0.8, and that gives us our estimate of the gradient vector. Ta-da!